We're going to continue our discussion of hybridization in geometry now. And we got lots of examples here. So we're going to do hybridization for each atom. We'll call that I. We'll do geometry name for each atom. It's pointed to. And bond angles. And remember what to count to do hybridization. What are the two things you count? Which bonds? Be careful. Only the sigma bond and the number of lone pairs. So the A is pointing to an atom that has 4 sigma bonds and 0 lone pairs. sp3. Had 4 fingers in the air. I'll just say 4 sigma plus 0 LP. Don't forget, I think we should put all the lone pairs on the atoms pointed to before we move on, because they affect geometry, right? And hybridization, right? You're counting them, they're going to affect hybridization. What about oxygen? Oh, sorry, nitrogen right there, B. How many lone pairs? How many lone pairs on that nitrogen? 1. It has an octet, people. You already see 3 of the bonds. What about the O? It's got 2 bonds. It needs 4 more electrons, but we know the nature. 2 bonds, 2 lone pairs. There you go. So that one was 3 sigma plus 1 LP. Hey, that's 4. That's sp3 again. I'm just going to do all these hybridizations first. Here we have 2 sigma plus 2 LP. That's 4. Same answer. Yes, sp3 all the way across. Not for D, it isn't. Hey, when there's 2 bonds, how many of them are sigma? 1. It's always 1. When there's 2 bonds in the other direction, how many of those are sigma? 1. 2 sigmas, no lone pairs. Don't count pi. That's a total of 2. Hey, total of 2, put your 2 fingers up. There's always an S. And how many P's this time? Right there. 1 P. It's called SP. So let's get a box on our answer here. There's a dead spot I hate on the screen here. There. Nice straight line for me. Pretty good. And I don't know why. This box won't have an end. There we go. sp3. Okay. When you're sp3, I'm going to go straight to bond angles because hybridization gives bond angles immediately. Immediately. sp3, 109.5 every time. That's because you got 4 things around the central atom. They're going to have the smallest angle. sp, there's only 2 things around the central atom. sp, 2. So that's the biggest bond angle. What's that? Okay, we forgot. It's called linear, 180. Oh, write down the linear too if you want. And I got all 3 of the possible sp3 scenarios here. There's 3 geometries called sp3. 3 of them. We got them all here. The one where they're all sigma bonds. Who remembers the name of that geometry? That's A. That's this first molecule. Tetrahedral. Named after the 4-sided figure with 4 triangles. If you connect the outside, you get triangles. Okay, a tetrahedron with one of the corners, quote unquote, missing. It's not missing, it's a lone pair. You don't see it. So it pushes the other bonds down just like a bond would, and you get what's called a pyramid, right? And you don't have to say it's a trigonal pyramid because we only have one pyramid in this course, and it is the trigonal pyramid. There's no square pyramidal in this course, so let's not have two pyramidals. Yay! We like less things, right? And when two of the corners are missing, don't say linear. Those lone pairs push those bonds down. It's not linear. Lone pairs are very important. They're just not used to describe the geometry. Bent. All right, ready for the big molecule? I just go I, and I underneath the letters and write three things. I can do that. Lone pairs, two lone pairs. Two lone pairs here, I think are needed for the hybridization. One lone pair here, two lone pairs there. E looks just like C, doesn't it? We just copy the answer for C. SP3, bent, 109.5. F. F, you got to be careful counting those sigma bonds. Careful. It has a sigma bond to the left. Only one of those two bonds is a sigma, right? It has a sigma bond to the carbon to the right. It also has a sigma bond to the H. The H is not in between the carbons. You know better than that, right? It's a sigma bond to the H. So that's three sigma bonds. To the H, to the C, and one of those is a sigma. And no lone pairs. 3 sigma, 0 lone pair. 3 sigma plus 0 LP. That's SP2. And this is the geometry that's in between 109.5 and 180 degrees. Not exactly, it's not an average of the two. But what is the angle that you learned for SP2? You forgot. It's okay. You won't forget after today because you only have 3 angles to learn, people. 120. And it's called Trigonal Planar. I dare you to draw a triangle that's not planar. You can't. So it's kind of goofy, the name, but we got to live with it. G, I'm going to do to the right because I don't have room to write under the G. G. It's got 3 sigmas. Do you agree? And 0 LP. What's your hybridization when you have 3 sigmas and 0 LP? I got 3 fingers in the air. SP2. G is, I wrote the SP2 right beside the other one. And hey, isn't it just like the other SP2? 3 sigma bonds, no lone pairs. Same answer. Trig planar. That's a short form I'll accept. And we just have H. We're not going to do the geometry for a simple reason. It's not a central atom. It's sticking off of something as its geometry. How's that? You say that about any atom that's just sticking off the edge of something. It's only got one thing attached. So I'm just going to do the blue part. It's got 1 sigma plus 2 LP. That's 3 things, right? Just 3 fingers in the air. What do you got? I got SP2. No geometry. And a repeat. Not a central atom. But I can do the hybridization and the bond angle is a waste of time too, right? Here's your bond angle. It's attached to the next thing. There. Directly. And no angle. But I can tell you the lone pair is 120 degrees from the sigma bond. You knew that when you said sp2, right? You can say the lone pair is 120 degrees from the sigma bond because that's the electron arrangement for every sp2. Okay? And that ends that activity. No, it does not. We didn't do part 2, did we? No. Part 2 is okay. Hey, there's an alcohol. How do you know it's an alcohol? It's got an OH attached to a carbon, and the carbon is not a carbonyl. If it was a carbonyl, carbon attached to the OH, you'd say carboxylic acid. It's not that. It's an alcohol. And when you do alcohols, you ask yourself, how many bonds does that carbon have to carbons? That was the wrong highlighter. I wanted a lighter blue. There's the only bond, and it's primary. So alcohols, you look at the carbon attached to the OH and ask yourself how many carbons are bonded to it. When it's 1, it's primary. When it's 2, it's secondary. When it's 3, it's tertiary. When it's 4, it's an octet violation. So we don't have 4, right? You can't have 4 bonds to carbon and a bond to OH. Now, amines, this next one's an amine. Nitrogen functional groups are amines. That's this example. Why I did that, I don't know. Or amide with a D. That's this example. There's a nitrogen attached to a carbonyl. Why not? I'm going to do amide right up there. You're not done. Not with those functional groups. Amines and amides both need a degree sign as well, and it's a different system than alcohols. Do not use the same rules for alcohols and amines. The amine rules are look directly at the nitrogen and ask yourself the question. How many bonds does the nitrogen have to carbon? And I'll do that in yellow highlighter. The nitrogen has 1 bond to carbon. Primary amine. In the amide, there's a bond to the C here. That's not a highlighter. That was a very bold highlighter. To the carbon here and to the carbon here. It's 2 bonds to carbon. What kind of amide is it? Secondary amide. And we're losing sight of our answers, so all of the question 2s are going to be circled in red. This one is called an ether. You have to learn this. You don't put a degree sign with ethers, even though they have an oxygen. We don't classify them that way. There's actually no functional groups in the next molecule with a D. You can say there's alkenes in there, but I don't consider those functional groups. If you did, I would say, okay, but I'm not giving you a point. There's nothing wrong with it. Yeah. On which one? The top one? It's the CH3. Yeah, that nitrogen's bonded to the CH3 and it's bonded to the carbonyl carbon, the C below. That's 2 bonds to carbon. Maybe I shouldn't have highlighted the H. I don't know. Move my highlighting. Shrink my highlighting? Do I? Can't fix it. They're associated with each other. The top one has a few functional groups. Carboxylic acid here. Looks like an alcohol because it has an OH on a carbon. But the carbon is a carbonyl. That's a C with a double bond to O. You'll be reading about this. So there's another functional group with a carbonyl. Carboxylic acid, amide, They both have carbonyl. And I think I got all the functional groups on this page. If you want, I'll do it here, because in the morning section I did do them. There's an alkene on the left, and an alkene on the right. Carbon double bonded to carbon. You can call it a functional group. But when you're reading chapter 1, it won't be listed there. It comes up in its own chapter, chapter 5, and chapter 6, alkenes, then chapter 7, alkynes. Yeah, all the functional groups get their own chapters eventually, okay? That's the story. They have their own behavior, their characters in the story. We have to learn them based on their behavior. And that is all I have for today. Please watch both sets of videos. They're doing more examples of the same thing. I might say something more clearly in the morning or the evening or vice versa. One might work better for you. So maybe really focus on the one you were here for, section 70 video. And for more, you know, a little more clarity, and just watch it through instead of taking notes as you're going. Do the morning section, like just a watch through and see if it makes sense, right? I think that's a suggestion that might be worth checking out. I just thought of it. Okay. All right, so here we go. And I want you to have a great weekend. And unlike the morning section, I'm going to remind you